Hello and welcome to TechSchkool. So today is the topic of today's discussion is going to be a question of DSA, and I'm going to add this into a series of LeetCode. So actually we'll be solving all of the LeetCode problems in Top Interview 150. So if you don't know, LeetCode is a very good platform where you can prepare for your DSA interviews, and they have a study course of Top Interview 150. So that's like 150 questions of LeetCode, which I think they seem to think that if you prepare that, you are going to do very good. So what we are going to do in this series is we are going to take each of those problems and we are going to solve them, and we are going to find what's the best way. We are going to define like what is the best way to solve each of those problems, how to optimize it, how to get the best time complexity, best space complexity, and all of that good stuff. So I'm going to start with the very first one, that is merge sorted array. Okay, I have it open here. So if you have clicked this video, you probably already know what the problem statement states, but I will still read it out for people who have not yet gone to that or who don't have an idea of the problem statement properly. So let's see what we are dealing with here. You are given two integer arrays, nums1 and nums2, sorted in non-decreasing order. That means it's in ascending order. And two integers, m and n, representing number of elements in nums1 and nums2 respectively. So that's very simple. If you look in our code over here, you can see that we have an integer array, that is nums1. The size of that integer array, number of elements in nums1 is m is the number of elements in nums1. Similarly, we have nums2, and n is the number of elements in nums2. All right, merge nums1 and nums2 into a single array sorted in non-decreasing order. So what we need is nums1 and nums2 has to be merged into a single array, and it also has to be in ascending order. Pretty simple to understand, I guess. Okay, let's read further. The final sorted array should not be returned by the function, but instead be stored inside the array nums1. So this is the game changer statement over here. I mean, this is a very important statement that we have to read here carefully. I'll read it again. The final sorted array should not be returned by the function, but instead be stored inside the array nums1. So if you look carefully at our function, our return type is void. That means this problem is not expecting us to return an array. So when we are sorting this array, this sorted array should be stored within nums1. So in other words, we have to modify nums1 itself, and our sorted array should be present in that. So we don't have to return another array, we just have to modify nums1. To accommodate this, nums1 has a length of m plus n, where the first m elements denote the elements that should be merged, and the last n elements are set to 0 and should be ignored. Nums2 has a length of n. So this is fair enough. They have given nums1 as the size of both the arrays, so that both the array's elements will fit within nums1, which is fair. And the first m elements are the actual elements of nums1, and the n elements are in nums2. So nums1 has enough space to accommodate elements of nums2. So I think the problem statement is very clear over here. We'll just look at some examples for more clarity. So always go through examples whenever you are in an interview or anything. Please sure to ask questions about the about whatever problem statement they're saying. Like if you get this question, if the interviewer says, write a code to merge two sorted arrays, you can ask them questions, right? Like, how do I exactly merge? Can I use an extra array, or do you want me to not use extra array? What should be the space complexity? What should be the time complexity that you're expecting? And all of these questions are good to ask, and actually gives you an edge when you ask those questions in the interview. So yeah, in examples you can see that nums1 array, right now in this example we have 1, 2, 3, and the rest 3 are 0, obviously to accommodate accommodate the elements in nums2. And in nums2 we have 2, 5, 6. And if you look at the output, you can see that both these arrays have been merged and they are in ascending order. So 1, 2, 2, 3, 5, 6. These are in ascending order. Pretty fair enough. If you look here, nums1, this has one element in it. Nums2 is an empty array. And when they are merged, they are getting 1 as the output. Here we have nums1 as 0, nums2 as 1, and the output is 1. So yeah, note that because m is equal to 0, there are no elements in nums1. Yeah, so see, since because m equal to 0, there are no elements, so that means they can just take the entire nums2 as the answer. All right, I think let's move on to our discussion now, where we'll actually discuss on ways this can be solved. So the first and the easiest way to do this is actually get a new array. Okay, so I'm going to act as if we have a new array, that is array number 3. Mind you, this is not the best approach. I will also come to the best approach, so please watch the video till end so that you can see what is the most optimized approach, which will have time complexity of 0 of n and space complexity as 0 n as well. Sorry, the space complexity, let me just modify that. The space complexity will be 0, 1. So in this scenario, we're actually going to be using the first scenario that I'm discussing is where we're going to be actually using the brute force approach, or the approach where we're actually using another array to do this work. You can directly skip to the optimized approach path. I've added the timestamps at the end of this video for that purpose. But those who want to really understand, we can also go with the brute force approach first. In interviews as well, it's always good that you start with the brute force approach and then you move on to the optimized solution. So I guess interviewers will actually get a good idea that, okay, you actually have a good hold over the concept and you know what you're doing, right? So it's always good to start with a brute force approach first. So yeah, how is this scenario is, I'm going to just dive right into it. Okay, so I'm just going to use 2 pointers. This pinkish whatever pointer is pointing to the first element of array 1, and this blue pointer is pointing to array 2, first element of array 2. So it's very simple. I think you must have guessed it already. We are going to compare these 2 elements. So between 1 and 2, we know that 1 is the smaller one. So first in our array, we will enter 1 and we will increment this pointer to the next step. Now in the next iteration, this pointer will remain here because we have not entered it into the array yet. But here you can see that they are equal. So we will have to enter both of them into the array. So within this array, I am going to enter 2 and that 2 as well. And we will have to increment both these pointers to the next. Now, in comparison, between 3 and 5, which one is the smaller one? 3 is the smaller one. So in our array, we are going to enter 3. And we are going to now increment this pointer. So now this won't increment actually. That is the end of our array. That will be the end of our while loop, because now we will have m as 3, right? So when it goes here, it will actually be equal to 3. So that means when it's at the 3rd index, we have to stop the iteration. And since array 2 has elements remaining, we will just enter all the elements in array 2 directly into our final array, 5 and 6. So now we have entered the final elements within the array which was not completed, and now we can just copy this array into array 1. So you can just copy this into array 1, because as I mentioned earlier in the video, I mean in the question itself, it's mentioned that we cannot have another array, we cannot return it, we just have to modify array 1. So we will have to enter these values into array 1. That would be another for loop just to enter those values, and then that's how you would solve that this question. And this is not the recommended approach because it will take a space complexity of n, okay, which is not ideal, right? So I will delete this. And now how are we going to do it without using another array? We just want that we are using this array 1, array 2. We have both these arrays and we just want to in place modify this array without using another array. So of course, when you think, the best way to go about this is to go from the back, like how we were iterating from the front of the array. Since this is an ascending order, what if we start iterating from the last element in each array? So I have placed my pointer to the last element of each array. So you know that you are starting, because we are going to, like, what is the plan of action I'm suggesting here is that we start filling elements right from the last element, from the last spot. So even for filling the elements, I think I will have a pointer here. This is the actual pointer which is going to fill the elements into the array. I will have our modified array over here. Just for reference, we are going to be modifying the same array. It's not a new array. So we will be filling 2, 3, 0, 0. And now the last spot, I will leave it empty. So now the first thing is what we're going to do is we are going to fill the last spot. Okay. So now how is that going to happen? We are going to start iterating from the last elements of each array, because those will be the greatest elements. So then if we want to fill the last spot of our final array, we will always want to know which would be the greatest from both of them, right? So let's compare 6 and 3. Which one is greater? Obviously 6 is the greater one. So since 6 is the greater one, our last element is going to be 6. Okay. And we will have to do two things. This pointer will get decremented to 5, and now our positioning array pointer will also be decremented by 1 step. We won't move this pointer as we have not entered that element yet. Okay. Now again there will be a comparison between 5 and 3. Which one is greater? Obviously 5 is greater. So we will decrement this by 1 step. We will enter this element in this one. So we're going to enter 5 here, and then our positioning pointer will again move to 1 step here. Alright, now again we are going to compare 2 and 3. Finally, now we have 3 as the greater element, so we will now move this pointer, will decrement it, and 3 will be entered at this position in the array. So here we have 3 entered. Fine. And this pointer, the positioning pointer, is moved to this stage. Alright, pretty simple so far. Okay, now 2 and 2 comparison. Of course, what we can say is they are equal. So we can just enter any one of them. So I will enter this 2. I will decrement this pointer here. And now our positioning pointer is at the 3rd position. So at the 3rd position in our array, I'm going to enter 2. Alright, now again between 2 and 1, 2 is the greater one. So now I will enter 2. Already 2 is there, so I'm not going to change that. But our positioning pointer is again moved to the decremented by 1 step. And this position pointer is now out of the array, right? So we stop our operations there, and we look at the other array pointer. It is still pointing to 1 element, right? It's still within the array. So whatever it's pointing to, it will enter that. So 1 will be entered automatically, and this will also go out of the loop. And that is how we are going to merge these two sorted arrays, within one array. So I think if we actually go deep dive into the code, this will become more clear for you. So let's actually go to the code and see, actually write the code and see how we are going to do it. So for now, I will be writing the code in Java, but do let me know if you need me to write in C++ or Python or whatever, I can actually do that. So for now, I'm more comfortable in Java, so I'm actually going to do in Java. Alright. So here, as I mentioned, we have nums1. That's our first array. M is the number of elements in nums1. Nums2 is our second array. N is the number of elements in nums2. So before we start a program, writing a code as such, as I showed you, we used 3 pointers here, right? So in the first, when we started, this pointer was pointing at this element, this pointer was pointing at the last element here, and this pointer was pointing at the last element of our final array, right? So we need to set our pointers to these locations first. So let's do that. I'm going to type here int I will be our, if you look here, I will be our pointer in the first array. And so if you look here, our first array is nums1, and there are 3 elements in the first array. So that means our first array's last element will be positioned at m-1, because in arrays our counting starts with 0. So I will put it at m-1. So this is pointing to the last element. I will just put a comment, last element of nums1 array. Alright, then we are going to have our second pointer, which will be pointing to the last element of our second. Alright, so I will write that also, last. Please free to put in any doubts that you get in the comment section. I'll be happy to reply to all of your doubts. Alright, and the third pointer. So now we have completed this pointer and this pointer. Now we want to define this pointer, and as you can see, this is at the last position of the first array. So since we know that the first array size is the size of m plus n, and the last element should be minusing 1 because our counting starts from 0. So our last pointer, I'll name it as k, will be m plus n minus 1. Alright, now our pointers are set. Now I'll go back to the explanation to even reiterate what we discussed. So in our discussion, what we were doing is we are starting to decrement these pointers based on what is being entered into our array. We are decrementing these first 2 pointers, right? So in our code, I'm going to write a while loop while I is greater than and equal to 0, because as we keep decrementing I, it can reach a point where it is getting out of the array, like how in this scenario this pointer went out of the array. So as long as both these pointers, so let it be like and so these 2 conditions must always be there for this while loop to run. While both of them are greater than or equal to 0, we want this program to run. So what are we doing? What were we doing at each iteration step when this was here? We compared these 2 elements, right? And whichever one was the greater one, that was getting entered at wherever this pointer is at, right? So what we'll do is we are going to compare those 2 numbers. So if, let's compare the first the first array element at I and the second array element at j. So I will write if nums1 at I is greater than, we're checking for greater than nums2 at j. If this is greater, what must we do? We know that k is going to be our positioning, I will write that here, positioning index, positioning pointer, I'll say pointer. So wherever k is, because since k is at the last, we want the greatest element to be at the last. So when we are comparing 3 and 6, we want that if nums1, that means if the array at the nums1 index, if it is the greater one, our nums1 at k index, that is the last index of nums1, should get the number which is greater. Okay, so right now here we can see that nums1 of I is greater. So I'm going to write nums1 of, what am I doing? Nums1 of I. But here's one thing that we need to decrement each of them. For simplicity, you can write after this that decrement k. But what I'm going to do is I'm going to just decrement them here itself. What this actually does is, since I'm doing a post decrement, there's a difference between pre-decrement and post decrement. Since I'm decrementing it after this, so it will first assign the value and then it will decrement. Okay, so it will first assign the value at your last element, and after that the k index will be decremented. Similarly, it will first place the value of ith index over there, and then it will decrement. So this is post decrement. You can do a pre-decrement as well. So this is, if you do pre-decrement, it will decrement the value of k first and then it will assign the value to that location. But since we want to first assign the value and then decrement k, I am doing a post decrement here. Okay, if any doubts are about that, I can explain in more detail in another video probably. So just comment down if you are getting confused about this thing. But I mean, if you're just getting confused, you can just directly, after you have written this, you can just do k minus minus I minus minus. No one is going to say anything. It's just for efficiency and for the code to look neater, I am just putting it in there. All right, in the else scenario, that means that nums2 of j is the greater one. So obviously our nums1 position at k should get the element at nums2 of j, and even that has to be decremented. I hope this is crystal clear to you. So this while loop will keep on going until and unless one of these pointers gets out of the array. So if any one of them gets out of the array, we will come out of the while loop, right? So let me just, all right, so once we're out of the while loop, we want to enter all the remaining elements. So we don't know at this point that which element has values remaining. So I am just going to write two while loops here. So one is for the nums1 array and one will be for the nums2 array. So for nums1, while I, so what will happen here is, if it's already out of the nums1 array, it won't even enter this while loop. You know, if it's already our this has gone lesser, it won't even enter this while loop, right? So what I will write is nums1 k minus minus will be equal to nums1 I minus minus. All right, and similarly for our second array, if that is the one which has pending elements, then this will enter this one. So you should understand that our either one of these while loops are going to run. It won't happen that both of them are going to run, because it's only coming out of the earlier while loop when one of them is running out. I wrote something wrong here. Nums1 k minus minus equals to nums2 j minus minus. So I hope this makes sense to you. We can test this code. I will just run it. Yep, it's accepted. As you can see that it has accepted our test cases. All the test cases are accepted. You can see that this was the input. The expected output is same as the output provided by our code. Similarly in case 2 also, the expected is same as our this, and in case 3 as well, expected and the output provided by us is also same. So let's just submit it and see what is the scenario there. Yep, so you can see that it's accepted. 59 out of 59 test cases have passed. So yeah, that's it. We have successfully completed this question, and I hope that explanation was clear. I am just starting off, so I am not a very full-fledged trainer, but I hope that I've made it clear. If you need any clarification on any of the things that I've discussed, please feel free to comment down below. Any feedback is appreciated. If you like the video, just like, share, and even subscribe. Yep, that's it for today. Thanks for joining. I'll stop it. More such videos to come, guys. So yeah, bye bye.